everybody, welcome to the videos for the cumulative review packet number 12. In this video we will be going through numbers 1 to 3. So if we take a look at number 1, we have 27x cubed minus 64. Now before we start the problem, I would like to point out, because the highest power is 3, I know that there will be 3 zeros or 3 solutions in the end. So if I decide to just add 64, divide by 27, and take the cube root, that's only going to get me one answer, not 3. What I notice, though, is that both 27 and 64 are both perfect cubes, and I notice that this is given as a binomial. Whenever I have a binomial or two terms where I have perfect cubes, this should lead to same opposite always positive, or SOAP. So what we do to start this problem to make sure we get all 3 answers, some of which might be imaginary, is we say that the a term is the cube root of 27, which is 3. The cube root of x to the third is x, because both of these things times themselves 3 times give you this. The b term, what times itself 3 times gives you 64, is 4. Because I have a minus sign, the SOAP formula I'm going to follow is a minus b, a squared plus ab plus b squared. So, in this case, if I use these a's and b's, we would have 3x minus 4. Now here, if I am squaring 3x, I have to square both the 3 and the x. So I would have 9x squared, not 3x squared, plus a times b. So 3x times 4 is 12x. And then b squared, 4 squared is 16. And all of this still equals 0. If I'd like to solve both pieces separately, this first piece is pretty quick. 3x minus 4 equals 0, so 3x equals 4, so x equals 4/3. Before I box this, I'm going to check it in a little bit. But this piece here, let's first check to see if it factors. If I try to factor it, I see perfect squares on the ends, so I'd get 3x and 3x. I would get 4 and 4. But then I notice, if I think about doing FOIL backwards, that I have 12x here and 12x here. Can I ever get 12x and 12x to add to be 12x? No. Which means that this does not factor, which means I need to rely on a different method. I would say the other method that would be best here is quadratic formula, because my lead coefficient is not 1, so completing the square would make everything harder. So we'd have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that would be x equals negative 12 plus or minus the square root of 144. I only see one subtraction sign here. Negative times positive, so it's still negative. 4 times 9 times 16 is 576. All over 18. So x would equal negative 12 plus or minus the square root. 144 minus 576 is negative 432, all divided by 18. Now if I think about 432, that's pretty large. So I can split that into 144 times 3, because 144 is a perfect square. So that'd be x equals negative 12 plus or minus the square root of negative 144 times the square root of 3 all over 18. So that would be x equals negative 12 plus or minus 12i, square root of 144 is 12, but imaginary, root 3 all over 18. I now notice, now that I split the radical, I have this triangle of numbers that I can take a greatest common factor. All of these are divisible by 6. So we'd have x equals negative 2 plus or minus 2i root 3 all over 3. Now, because this answer is complex, I would prefer, if your answer, I know Mr. Marconi would as well, to write it in the a plus bi format, which would be negative 2/3 plus or minus 2i root 3 over 3. And so this is how we'd like to see it on your test. Now, in terms of checking, we said in class we do not want you to check the imaginary answers, but we would like you to check to see if 4/3 works. So if I do my checking over here, here's my original problem, 27x cubed minus 64 should equal 0. And I think that an answer is 4/3. So you'd have 27 times 4/3 to the third minus 64 should equal 0. This example, it's actually easier to keep the answers a fraction, because if I cube both 4 and 3 separately, I would have 27 times 64 over 27, if I cube both numbers, minus 64 equals 0. I then notice that the 27's cross out, so I'm left with 64 minus 64, which does equal 0, so 4/3 for sure works. Number 2, 6x to the fourth minus 5x squared minus 21. There is not a greatest common factor at the beginning of this problem, so that's unfortunate. But I do notice that when I start with a even power, I could try to factor with split the middle. So let's try that. If I did a times c, which was 6 times negative 21, that would get me a product of negative 126. Now what you could do, of course, is list all the pairs of numbers that multiply to be 126, but I know the pair has to add to be negative 5. So I already did this work, and I found that the pair of numbers that works is 9 times 14 gets me negative 126, but to get negative 5, I need negative 14 and positive 9. So remember, when you split the middle, and the middle term is x squared, you need to split it, and both of these need an x squared. So I'm going to put 9x squared here, and I'm going to put minus 14x squared here. And then I'm going to carry down the 21 from the original, and I'm going to carry down the 6x to the fourth from the original. So now I have a factoring by grouping problem. So if I group these first two together, I can take out a 3x squared, and left in the parentheses would be 2x squared plus 3. And from the second pair, I could take out a negative 7. And if I divide both these by negative 7, I am also left with 2x squared plus 3. And all of this still equals 0. So if I continue to factor by grouping, I have 2x squared plus 3 as one parenthesis, and 3x squared minus 7 as the other parenthesis. So if I set these both equal to 0, 2x squared plus 3 equals 0, and I solve this piece, I would have 2x squared equals negative 3, which means that x squared would equal negative 3/2. So I already know my answers are going to be imaginary. When I take the square root, I have x equals plus or minus the square root of negative 3, technically over the square root of 2. I split this into two radicals because this helps me see that I need to rationalize. Even though it's imaginary, you still need to rationalize. So you multiply top and bottom by root 2. So x would equal plus or minus square root of negative 6 over 2, which is better written as plus or minus I root 6 over 2. And because those answers are imaginary, we're not going to have that you check them for this test. So those are two answers, but I know that there should be 4 because of the highest exponent. So if I set the other one equal to 0, so if I do 3x squared minus 7 equals 0, that would be 3x squared equals 7. So x squared equals 7/3. If I take the square root of both sides, I will get x equals plus or minus the square root of 7 over the square root of 3. Both not perfect squares, so I again have to rationalize here. Multiply top and bottom by root 3. Get x equals plus or minus root 21 over 3. Because these are not imaginary, we would have to check them. And to do that, I would figure out what this is as a decimal. I did that already. This would be plus or minus, let's keep a few decimal places, 1.5275. So if I'd like to check, I'm going to use the original equation, 6x squared, 6x to the fourth minus 5x squared minus 21 equals 0. And so, if I plug in 1.5275, raise that to the fourth, subtract 5 times 1.5275 squared, and subtract 21, my answer should be 0. So, I did this already as well. When I plugged this into the calculator, I got 32.66. When I plugged this into the calculator, I got 11.66 minus 21. 32.66 minus 11.66 is 21. Minus 21 does equal 0. So I knew that the positive answer had to work. The good news is I know that the negative answer is going to work as well, because if I plug negative this answer and negative this answer into something that's raised to the fourth and raised to the second, both of these are going to come out positive anyway, which means that both the positive and negative answers work. Hurrah! The last example here is absolute value, and absolute value equations generally start the same way. You know that whatever is inside an absolute value bar could originally be positive, or what's inside could originally be negative. Either way, your answer would come out as a positive. So either x squared plus 4x, the positive, equals 3x plus 6, or this as a negative number, which we represent as negative x squared plus 4x, equals 3x plus 6. And so we'd have to solve both of these separately. This one, we would have x squared, let's move these over here, plus x minus 6 equals 0. So let's check to see if this can be factored. X times x, 3 and 2 plus minus. So my two possible answers are negative 3 and 2. We'll check them soon. Here, if I distribute the negative first, we have negative x squared minus 4x equals 3x plus 6, which would be negative x squared, move these over, minus 7x minus 6 equals 0. I'm going to divide everything by negative 1 to make my life easier. X squared plus 7x plus 6 equals 0. Let's check to see if this factors as well. X times x is x squared. Two numbers that multiply to be 6 and add to be 7. Why, that's 6 and 1. How lovely. So my two possible answers from here are negative 6 and negative 1. So let's start checking these into the original. So let's see. If I want to check negative 3, I would have negative 3 squared is 9, plus 4 times negative 3, which is negative 12. So does the absolute value of negative 3 equal negative 3 times 3 is negative 9 plus 6. So does the absolute value of negative 3 equal positive 3? Does the absolute value of negative 3, which is 3, equal negative 3? No. So negative 3 does not work. Let's try 2. If I plug 2 into the original, the absolute value of 2 squared, which is 4, plus 2 times 4 is 8. So does the absolute value of 12 equal 3 times 2, which is 6 plus 6? Does the absolute value of 12, which is 12, equal 12? Yes, it does. So x equals 2 is for sure an answer. Let's check negative 6 and 1. So my original problem is the absolute value of negative 6 squared, or 36, plus 4 times negative 6, that's really minus 24. Does the absolute value of that equal negative 18 plus 6? So 36 minus 24 is 12. Does the absolute value of 12 equal negative 12? No, because the absolute value of 12 is 12. 12 does not equal negative 12, so see you later, negative 6. Let's try negative 1. So the absolute value of negative 1 squared is 1 plus 4 times negative 1, which is plus a negative 4. Does the absolute value of negative 3 equal 3 times negative 1, negative 3 plus 6? Does the absolute value of negative 3 equal 3? Why, yes, it does. So my two answers are x equals 2 and x equals negative 1. On your test, please make sure that you have the time to check your answers. As you can see on this one, we had 4 originally, and only 2 of them worked. So it is good to take the time to check. Thanks, everybody.